Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. Good evening.
Good evening, ma'am.
Good evening. Good evening. Good evening, children. Good evening. Yeah, I think we have to continue from here. So this one says a vessel is in the form of an inverted cone. A vessel is in the form of an inverted cone. See, when you draw the cone, when you draw a cone, you draw it like this. You make it stand on its base, circular base. Because a circle has, a cone has, one end of the cone is a circle, the other one is a fine tip. You cannot make a cone stand on this. Now when you have this ice cream cone, you hold it in your hand. You cannot keep it on the table. That's an inverted cone. This ice cream cone, when you have it in your hand, is an inverted cone. It's an inverted cone because you have to hold it. You cannot place it on the table. Because if you place it, then it has to stand on its tip, its vertex, which is not possible. This is a cone, children. This is a cone. When you draw the cone like this, it's called an inverted cone. That's all. A vessel is in the form of an inverted cone. A vessel is in the form of an inverted cone. This is a cone, children, which is made to stand on its circular base. When you have it like this, upside down like this, it's called an inverted cone. So you need to hold this. You cannot leave it on any surface. Inverted cone. This is an inverted cone. An inverted cone. A vessel is in the form of an inverted cone. Okay, a vessel is in the form of an inverted cone. Its height is 8 centimeters. Height 8 centimeters. Its height is 8 centimeters. And the radius of its top, which is open, is 5 centimeters. It's filled with water up to the brim. Okay, so it's filled with water up to the brim. It's filled with water up to the brim. When lead shots, each of which is a sphere. So these are the details about the cone. These are the details about the cone. Now coming to the spherical lead shots. The spherical lead shots. Coming to the spherical lead shots. Now for a sphere, you need only one thing, which is a radius. For a sphere, you need one thing, which is a radius. When lead shots, each of which is a sphere of radius 0.5 centimeters, 0.5 centimeters, 1/4. So how many lead shots you drop is not given. When lead shots, how many? 10, 20, 100, 200? Not given. When lead shots, each of which is a sphere of radius 0.5 centimeters, are dropped into the vessel, obviously water will flow out. The spheres will displace water and the water flows out. Because it's filled with water to the brim. If it was not filled with water to the brim, maybe the water level will only increase in the cone. And maybe after a certain point it will flow out. But here the cone is filled with water to the brim. So when you add lead shots, the water will flow out. The water overflows. Because the lead shots take up the space in the cone. When lead shots, each of which is a sphere of radius 0.5 centimeters, are dropped into the vessel, 1/4 of the volume, 1/4 of the water flows out. 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. So you need to make an equation in words. You need to make an equation in words. Now we have learned in science that the volume of the object that's dropped into the vessel will be equal to the volume of the water that flows out. The volume of the water that flows out is will exactly be equal to the volume of the object that has taken the place inside the cone. But here, not one object, many lead shots are dropped, identical lead shots. So the volume of all the lead shots will be equal to the volume of the water that overflows. That is the equation in words. Volume of all the lead shots. Volume of all the lead shots is will be equal to the volume of the water that overflows. Or that has overflown, whatever. Okay. Volume of the water that overflows. Volume of all the lead shots. Okay, volume of all the lead shots that have been dropped into the conical vessel, the volume of all the lead shots will be equal to the volume of the water that overflows. This is the equation in words. That's all. If you can write this, you've got the answer. Every time you read a question in volumes and surface area, either it'll be a direct one. That is, you just have to use a formula, substitute the values and get the answer. Questions like this, which is logical, where you need to understand and proceed, where you don't know whether you'll have to use volume or surface area, you don't know. See, when the question is find the curved surface area, find the total surface area, find the volume. So you just have to write the formula, substitute the values and calculate. In questions like this, you need to understand the situation and construct the equation in words. So this is the equation in words. Volume of all the lead shots is equal to the volume of the water that overflows. How will we find the volume of all the lead shots? Supposing there are n lead shots. N into volume of one sphere, 4 by 3 pi r cube. N into volume of one sphere, one spherical lead shot, volume of one spherical lead shot, 4 by 3 pi r cube. Into n will be the volume of all the lead shots, all the spherical lead shots. N is the number of lead shots that have been dropped into the conical vessel. Volume of one lead shot into all the lead shots will be the volume of all the lead shots is equal to the volume of the water that overflows. How much overflows? 1/4 overflows. 1/4 of the volume of the water overflows. So the total volume of the water in the cone is 1 by 3 pi r square h. The total volume of the water in the cone is equal to 1 by 3 pi r square h. 1/4 of this overflows. That's what is given. 1/4 of the water. How much ever is there? In that 1/4 overflows. So that means how much is there in the vessel? 1 by 3 pi r square h is there. Because it's a conical vessel. So what's the total volume of water in the vessel? 1 by 3 pi r square h. Does the entire thing overflow? No. How much overflows? Only 1 by 4 overflows. 1/4 of this overflows. So this is the equation. You just have to substitute the values in the appropriate places and simplify. Please do this. I'm not showing you the answer. Let's see if you all can work this. You can take 0.5 as 5 by 10 or 1 by 2. Don't work with decimals. 0.5 can be taken as 1 by 2. What is 0.5? 5 by 10 or 1 by 2. Everything is given. All values are given. You just have to substitute in this equation and solve. Quickly. Don't Google and tell me the answer. Don't look behind your NCERT textbook and tell me the answer. Please work. Class, use the emoji. Raise your hand. Shivani, Arnav, Shriya, Nafi, Manasa, Bala Harish, Shabri Grish, Sudarshan. Sudarshan is in the meeting, but he's studying for tomorrow's exam at school. Hi, Sudarshan. Oh, you're there. Okay.
Can you hear me?
Yeah, yeah. Okay. Justin, please start working.
Ma'am is N100.
Done the calculation, is it, Arna?
Yes, ma'am, I'll send it.
No. I trust everybody here. Okay. I think I shouldn't have asked you that. Okay, fine, Arna. N is 100. Fine.
Yes, ma'am.
No, I didn't try to offend you.
No, I still wanted to share the working.
Okay.
To show that.
Okay. Good. You are getting 100? Response. Well, I've got 0.5 here, so but I told you can take this 1/2. That will make your working more easy. You can take this as 1/2. That makes your working more easy, calculations easier. Please use 1/2. N is 100. Pi on either side gets cancelled. 3 on either side gets cancelled. You can cancel pi on both the sides. Pi on both the sides, 3 on both the sides. R square h. 5 square h. 5 square into 8 by 4. Three on both the sides gets cancelled. Pi gets cancelled. N into 4 into radius of the sphere is 1 by 2. 1 by 2 whole cube is equal to, you can see r square h here. So 5 square into 8 by the denominator here 4. Simplify that. 1 by 2 on the other side will become into 2 into 2 into 2. 1 by 2 on the other side will become 2 into 2 into 2. Or 1 by 2, the whole cube is 1 by 8. On the other side, it will become 8. Repeating, don't use 0.5. Yeah, children. So the answer is 100. Is it understood? Is that the equation understood? Volume of all the lead shots is equal to the volume of the water that overflows. You can write it here when you start the answer. Volume of all the lead shots is equal to volume of water that overflows. And maybe you can write it here. So, let the number of lead shots above the n. So here volume of all lead shots is equal to volume of water that overflows. So all the lead shots will be volume of all the n lead shots. And volume of the water that overflows is 1/4 the volume of the cone. Understood, children?
Yes, ma'am.
Okay. Yeah, this you can. Please read the question. Please read the question first. Have we get me a glass of water, no? Yeah. So you need to find the sum of the volumes of the two cylinders. For both the cylinders, you know their radii and heights. I've used a capital R, capital H for the big cylinder and small r, small h for the small cylinder. So the volume of the solid iron pole is the volume of this cylinder, pi capital R square capital H plus pi small r square small h. This is only about substituting the values. Pi into 12 square into 220. So here you can see I've just got the answer in pi. I told you that's completely your choice. You can also use 22/7. But supposing it's not exactly divisible, have it with the denominator 7. Don't find the decimal value. If it's exactly divisible, fine. If it's not divisible, don't find the decimal value by division. Have it as a fraction, something over 7. Now the mass will be the volume of the pole into mass per centimeter cube. Grams per centimeter cube. The volume of the pole is actually so many centimeter cube. So just multiply the value of pi here I've taken. This one into 22 by this pi value. 22/7 into 8. So that is so many grams because grams, 8 grams. So many grams or so many kilograms around it like this. So we have to take pi as 3.14. I've made a mistake. I've taken 22/7. We'll have to take as 3.14. Please use 3.14 children. I did not notice that. I don't think you should have any doubt in this answer, children. Shall we go to the next one? Shall we go to the next one, children?
Yes, ma'am.
Yes, ma'am.
Okay, I think I'll just put you on a test. Let me see. We'll take a test now. Please take the first question. I think you can do only that. Take a screenshot and do the first one alone. You can take a screenshot, but try only the first one, children. The first question. The volume is given, find the CSA. Yeah, so do that. And the first one here and the second one. That's right. Yeah, 1 minute. Please work. The earlier screenshot, I said work only the first one, correct? Yeah, if one of you acknowledge, at least one.
Yes, ma'am.
Okay, thank you. Manasa?
Shreya, ma'am.
Yeah. Thank you, Shreya. So that is the first question. What this is the second one? What this is the second one? This one, the third one, and this is the fourth one. So I'll put you with 4 questions. Please work that. I'll get back in some 10 minutes. The second question which you see here on the screen is similar to what we just finished working. A vessel is in the form of an inverted cone. Its height is 11 centimeters. Similar to that. I'll get back in 10 minutes, children. Please work these sums. What's the status, children? How many sums have you finished?
Ma'am, almost completed the third one.
Third. So 1 and 2 fully completed, is it?
Yes, ma'am.
Okay. What's the answer for the first one? What's the CSA?
693 centimeters square.
Please repeat.
693 centimeters square.
693 centimeters square. Okay, let's see. So we are given the volume of a hemisphere. So what's the radius of the hemisphere? What is the radius from the volume? We should first find the radius of the hemisphere. What is the radius?
10.5.
10.5 or 21 by 2 centimeters. And CSA 693. So let's see. Yes, Arnav, you are right. Arnav is right. Please see the answer, children. Volume is given. That means 2 by 3 pi r cube, because volume of a hemisphere 2 by 3 pi r cubed is when you convert it to a mixed, when you convert the mixed fraction to an improper fraction, that's what you get, 4851 by 2. And on working that, so you should see that you should not multiply. You must break down the numbers into their factors. See how it's calculated. $441 you should know is 21 into 21. So there's 20, this is 21 into 21, and there's another 21 here. 7 3s are 21. So there are 3 21s. R cubed is this. So for R, you will get 121 out. And in the denominator, 2, 2, 2. So 1, 2 comes out. So 21 by 2. On simplifying, 445, 37. See, I've written 37 as it is. 441, break it down into its factors. 3 into 3 into 7 into 7. And then 2, 2, 2. So it is 3 cubed, 7 cubed, 2 cubed. So from 3 3s, 1 3 out. From 3 7s, 1 7 out. From 3 2s, 1 2 out. R is equal to 3 into 7 by 2, 21 by 2. CSA is 2 pi r square. 2 pi r square, 693 centimeters square. This was easy. I don't know why the others did not answer. Lower your hands, class. Rafi, Bala, Harish, and Sudarshan. Lower your hand. Okay, if you have not done this, take a screenshot. Take a picture and complete it, children. See, you should know the formulae. We've seen them in 9th standard. That was about the first one. What's the answer for this one? The second one, what's the answer for this? How many spherical lead shots have been brought to the conical axis?
440.
440.
Yes, ma'am.
Is that Arnav again?
Yes, ma'am.
Okay, what are the others doing? Children? A similar one we just worked, right? Okay, 440. Yes, you're right. So there it was 1/4 of the volume of the water in the cone flows here. Flows. So 2 of H. Okay. Yeah, I think I asked you. Have you finished this?
Yes, ma'am.
Okay, so what's the inner diameter of the shell?
16 centimeter.
16.
Yes, ma'am.
What is the equation in words?
The inner diameter of
And
the spherical copper shell.
Yeah.
The inner diameter of the spherical copper shell is 16 centimeter.
No, I'm asking you. Once having read the question, what is the equation that you frame in words? How did you start off the answer? What is the equation you constructed?
Ma'am, by using the formula, by using the sphere formula, 4/3 into pi, and since we are having external and internal, so capital R square minus small r square.
R square,
And then it's recasted into, yes, sorry ma'am, r cube is equal to 1 by the volume of a cone.
Correct. A spherical shell is recast into a cone. So a spherical shell is converted to a cone, is recast into a cone, which means the volume of the material in the spherical shell will be equal to the volume of the material in the cone. Volume of the spherical shell is equal to the volume of the cone. Volumes will be the same. When one solid is melted and recast into another solid, their volumes will remain the same. Assuming that there is no wastage in the conversion process. Into another solid, their volumes will be the same. Volume of the spherical shell is equal to the volume of the cone. 4 by 3 pi capital R cube minus small r cube, because it's a spherical shell. It's not a solid sphere. It's not 4 by 3 pi r cube. It's not a solid sphere. It's a spherical shell. 4 by 3 pi capital R cube minus small r cube is equal to 1 by 3 pi r square h. So the third, right? What was that?
Yes, ma'am.
Yeah, please write down those who have not finished. Done, children? Is it over? Yeah. I'd asked you to do this as the fourth one. This one is the fourth one. If you've not written the question, please write it down now. All right, now see the answer. Write down the answer, we'll discuss. It's mostly self-explanatory. So we're given the ratio of the volumes of two spheres. So I've called it the small sphere and big sphere. The ratio of their volume. So that means the volume of the small sphere by the volume of the big sphere, because ratio is 1728 by 2197. The volume of the small sphere, because the numerator is smaller than the denominator. The numerator is smaller than the denominator. So small sphere, big sphere. If the numerator was bigger, then it will be big sphere by the volume of the small sphere. The ratio of the volumes is given. Sphere, so 4 by 3 pi r cube. Small sphere, small r, capital, a big sphere, capital R. So from this you can find the ratio r by r, 12 by 13. You must know that 12 into 12 into 12 is, because this is r by r the whole cube, r cube by r cube, r by r the whole cube. So this one also should be expressed as a perfect cube. So 12 taken 3 times. 12 multiplied by itself 3 times is 1728. 13 multiplied with itself 3 times is 2197. So we have the ratio R by R is 12 by 13. But we have to find the surface area. We need to find the surface area of the big sphere. So now let's write the ratio. Now let's write the ratio of the surface areas. So surface area of the small sphere by the surface area of the big sphere is equal to surface area, right? So 4 pi r square by 4 pi r square. Now we are given the surface area of the small sphere are given 3024. Surface area of the big sphere we have to find is equal to here. We only have r square by r square, which is r by r the whole square. So r by r we know is 12 by 13. So on working this, the surface area of the big sphere is 3549 centimeters square. Yeah, let's continue with the exercise 13.2. Yeah, children, this is similar to example. This one is similar to example 2. Let me show you example 7. Similar to example 7, children. We found here the difference in the volumes. Similar question with different values, with bigger values. Okay, we understood example 7. So you can, I'll read the question for you. A solid consisting of a right circular cone. Cone's height is given, radius is given. Standing on a hemisphere, radius is given. And is placed upright in a right circular cylinder full of water, such that it touches the bottom. So what you need to understand here is the solid, which there in example 7 it was described as a toy. So here they call it the solid. What is the solid made up of? It's a hemisphere surmounted by a cone. The solid in example 7 it was called a toy. The toy is called the solid or is referred to as a solid, which is a hemisphere surmounted by a cone. Which is a hemisphere surmounted by a cone. So now this solid is placed inside a cylinder. This solid is placed inside a cylinder. The solid just touches the sides of the cylinder. It touches the bottom, it touches the sides, and it's of the same height. And you can see, find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeters and the height is 180 centimeters. So from the values of the cylinder, you can make out that the cylinder just circumscribes the solid. Let's see. Hemisphere. Hemisphere, where is the hemisphere? Hemisphere. Radius 60 centimeters. Okay. Cone. Cone. Height 120, radius 60. Height 120, radius 60. Okay. Cylinder. Radius 60, height 180. Radius 60, height 180. But since we already have H here, we call it H1, 180. Now you see that the radius is the same. 60, 60, 60. And the height of the cylinder, you see, is the height of the hemisphere plus the height of the cone. The height of the hemisphere is 60 because its radius is 60. The height of the cone is given 120. 120 plus 60 is 180, which is the height of the cylinder. So that means the solid just fits into the cylinder. The solid just fits into the cylinder. Because you can see the height of the head is 60. The height of the cone is 120. The total height of the solid is 180. The total height of the solid is solid. The total height of the solid is 90 centimeter, which is also the height of the given. So from these values, we understand that the cylinder circumscribes the solid. That is, the solid just fits into the cylinder. The volume of the water left will be volume of the cylinder minus the volume of the toy. Sorry, solid. Volume of the cylinder minus the volume of the solid. Finished, children? Converting centimeter cube to meter cube is not mandatory, but in centimeter cube, the value looks large. So I converted it to meter cube. Are we all taking my instruction? Finish writing this in your book?
Yes, ma'am.
Okay. The first step after reading the question is to write the values. Sphere, cone, and cylinder. Then we need to find the volume of the solid, which is the volume of the head, the volume of the cone. Hemisphere and cone together is a solid. Find that. Then find the volume of the cylinder. Subtract the two volumes to find the volume of the water left in the cylinder. See, children, you should not do this. Don't cancel 3 ones are 3 20s are and write 20 cubed. That's wrong. 3 ones are 3 20 times, so 20 square. Don't calculate like that. That's wrong. So after this, you should have written, 2 by 3 pi into 16 to 16 to 16. So 3 ones are 3 20s are like this. Okay, so one of solid, one of cylinder, right? Then I have used the value of pi. Get a decimal value. It's too large in centimeter cube, so I converted to meter cube. But if it's centimeter to meter, we divide by 100. Centimeter cube to meter cube, divide by 100 3 times. All right. Okay, so a spherical glass vessel has a cylindrical neck. Spherical glass vessel. What do you call this in your science lab? Beaker. Is it a beaker? It's not a beaker. Beaker is this. No, I don't know. Let me say I don't know. Is it a beaker? A spherical glass vessel with a cylindrical neck. What is it called? What do you call a vessel like this? With a cylindrical neck and a frustum of a cone like this.
Flask, ma'am.
Flask. This is a flask. This is a flask. This is a beaker. No, see the nose doesn't stick out like this. Yeah, I'm not the nose because but there's some, a nostril here to pour the liquid out of the beaker. That's what I'm trying to show here. It doesn't stick out like this. Slightly it might. Slightly it sticks out, I should say. Slightly sticks out. That's a beaker. What is this? Don't you call it a round bottomed flask? Am I wrong? Okay.
Flask only, ma'am.
Okay, flask. It's not a beaker, it's a flask. Read the question, children. So sometimes in MCQs, you will be asked to describe. Now, in the game Gilli Danda, Danda is a stick. Danda is a stick. In the game of Gilli Danda, Danda is a stick. Gilli is, you know, that piece which looks like this. Correct? Gilli looks like this. So a gilli is a combination of two solids, cylinder and cone. Gilli is a combination of two solids. It's a cylinder with it's a cylinder with conical ends. The two solids here are, see, in all there are three. There is one cylinder and two cones, but the solids involved here are cylinder and cone. Cylinder and cone. A gilli is a combination, or you can say it is a cylinder with conical ends. Cylinder with conical ends. Sometimes these are asked in objective questions. Do we understand?
Yes, ma'am.
Okay. Danda, the stick is cylindrical, long cylindrical. So this piece is hit with this. The gilli is laid on the ground, and the person holds the stick and hits the gilli. That it should fly in the air. It should come up in the air, and then he strikes it again. You watch a video, maybe you will understand better. So that's how this game of Gilli Danda is played, and Gilli is a combination of a cylinder and cone, and two cones, a cylinder with conical ends. A capsule is a cylinder with hemispherical ends. A capsule is a cylinder with hemispherical ends. A rocket is a cylinder surmounted by a cone. A rocket is a cylinder surmounted by a cone. Now, this round bottom flask is called surahi. It's surahi. So mostly used in the ancient times of the kings, the Mughal rulers mostly. It's called a surahi. The Hindi term surahi, which means a flask which is a cylindrical neck. A flask which is spherical with a cylindrical neck is a surahi. Remember this term because you might get a question like a surahi is a combination of what and what. The surahi is a combination of a sphere and a cylinder. This kind of a flask is a combination of a frustum and a cylinder, but since you don't have frustum this year, you can ignore it. This is a frustum of a cone and a cylindrical neck. A shuttlecock. A shuttlecock is also a combination of two solids, frustum of a cone and a hemisphere. Frustum of a cone and a hemisphere. This is the hemisphere. This is the frustum of a cone. Frustum of a cone and a hemisphere. A spherical glass vessel has a cylindrical neck, 8 centimeters long, and so cylinder, you know the height and diameter is given, so radius. and the diameter of the spherical part. So see, in the question from here to here, you have all the values. For the cylinder, you know the height and you know the radius. For the sphere, you know the radius. Diameter is given, so you can find the radius. What will be the volume of the spherical vessel? What will be the volume of the spherical vessel? What will be the volume of the spherical vessel, children? What's the volume of the spherical vessel? It's the volume of the sphere plus the volume of the cylinder. It's the volume of the sphere plus the volume of the cylinder. Yes or no?
Yes, ma'am.
Yes, ma'am.
Volume of the spherical vessel. This is the vessel. The entire thing is the vessel. What is the vessel made up of? It's made up of a cylinder and a sphere. The volume of sphere plus volume of cylinder is equal to the volume of a spherical vessel. That's all. You just have to find the answer, and a child, okay, some student finds the volume to be 345. 345. So you should check if the student is right or wrong. Check whether she's correct, taking the above as inside measurements and pi value 3.14. Nothing. You are just asked that. See, a student has already computed the volume of this spherical vessel, 345 centimeter cube. You have to check. So you have to check if the child has, computed the volume correctly or not. Please work it now, children. Let us draw the figure of this. This will do. Figure everywhere is important. If the figure is not given to you in the question, you will have to draw the figure based on the information given. See, since I use a calculator, I've continued with the decimal value. I'll tell you, please use 425 by 100. So 25, 16, 17 times by 4, 17 by 4. Seventeen divided by 4. You can use 17 by 4 everywhere, children. You can use 4.25 also. Or you can use 17 by 4. So this is further 110.354 into 3.14. Because pi value, no? Value of pi 3.14. Take as 3.14. So that gives us 346.51 centimeter. It's a little more than 345. It's a little more than 345. It's 346. It's a little more than 345. The volume is 346. It's more than 345. It's not 345. It's 346. So the child is incorrect. Or the student is incorrect. Approximately correct, but not exactly. So the child is incorrect in computing the volume. They're fine, children?
Yes, ma'am.
All right. With this, we come to the end of exercise 13.2. How many of you there in the class? 6 of us. Arnav, Balaharish, Nafi, Sudarshan, Shivani, and Shriya. All right, children. That's it for today's session. Thank you. Good night.
Thank you, ma'am.
Thank you, children. Good night.
Thank you.
Thank you. Good night.